Hello guys, I want to show that this function is continuous. Now, as you can see, function of x and y, is equal to all this when x not equal to 0 and y not equal to 0, and the same function is equal to 0 when x equal to 0 and y equal to 0. That means function of 0, 0, 0, is equal to 0. That's what they are telling us now. That means the function is defined. There are three things to know that a function is continuous. Let me tell you the theory. The first one is if the function is defined at the point 0. Now, as you can see, it's defined at 0. Yeah, so this is approved. Then the second one is if the limit exists. So we want to show whether the limit of this function exists. Then, if the limit of the function at the point, that means at limit x and y tends to 0 of the function is equal to this, is equal to the function at the point. So now, if this one, if it obeys this, and the limit exists, now you need to obey these three principles for the function to be continuous. So let's start now. The first one is obeyed at point 0, 0, which is this. It exists. So now let's continue now. Let's prove, let's see whether it is really continuous at the origin. So we have this one now like this. So let's take the limit at f equals at limit s tend to 0 and y tend to 0. Let's check of the function s cubed minus y cubed all over s squared plus y squared, okay, is equal to limit s tend to 0. Let's push y inside. Then here will be s cubed minus y, okay, minus 0 cubed all over s squared plus 0 squared, and which is equal to limit of x tend to 0. Then here will be s cubed over s squared, which is limit s tend to 0 x, and is equal to what? 0. Now let's take for y. Limit of y tend to 0. Then here will be what? 0 cubed minus y cubed all over 0 squared plus y squared. Limit of y tend to 0 minus y cubed over y squared, which is limit of y tend to 0 minus y, and is equal to 0. These two are the same. Then let's take for y equals mx on a straight line. Let's check. Limit of x tends to 0, y tends to mx of the whole function s cubed minus y cubed over s squared plus y squared is equal to limit of x tends to 0, y is what? mx all cube all over s squared plus mx all square is equal to limit of x tends to 0, s cube minus m cube s cube all over all over x squared plus m squared x squared is equal to limit as x tends to 0, then here will be x cubed into what? 1 minus m cubed all over x squared and x squared is common into 1 plus m squared, okay? This one is the same as the limit as x tends to 0. X squared will cancel x cubed, then we are left with x, 1 minus m cubed all over 1 plus m squared. And all this now, this one is equal to x is 0. 0, 1 minus m cubed over 1 plus m squared is equal to what? 0. So you see now that they are all the same even on a straight line. So let's check on a curve. On a curve, y equals mx squared. That means the limit of s tends to 0, y tends to ms squared of the same expression y cubed s squared plus y squared is equal to limit of x tends to 0, s cubed minus, here will be mx squared all cubed over x squared plus mx squared all squared, okay? Now this one is equal to limit of x tends to 0, s cubed minus m cubed x to the power 6 all over s squared plus m squared s to the power 4 is equal to limit x tends to 0. X cubed is common here, so here will be s cubed into 1 minus m cubed x squared, okay? All over x squared is common into 1 plus m squared x squared. Now x is 0. Let's check. Let's put it in. Okay, before putting it in, here you still have limit x tends to 0. If you cancel out, then you are left with x into 1 minus m cubed s cubed, okay, x squared, sorry, all over 1 plus m squared s squared. All right, am I right? Yes, yes. Okay, now, so we have s equal to 0 now. Now here will be 0 into 1 minus m cubed times 0 all over 1 plus m squared times 0. Everything here will be 0. So as you can see, they are all zeros. That means the limit exists. So the limit exists and is equal to what? 0. So remember, the function of 0, 0 is still 0. Check, which is this at point 0, 0. So as you can see, the function is defined, mark. Then the limit is 0 and the function at the point is 0. They are equal. That means the limit and the function f comma x comma y is continuous at point 0, 0 at the point. If you like this video, subscribe for more.